Alright, this video is a little different than my normal ones. I sort of moved into the garage here. My wife let me take the entire garage. And so I moved a bunch of stuff around, and I moved this thing around and then never quite got it up and running again. So it's time to get it running again. And it is a CNC router. And you can see it over here. It is completely home designed and home built. I wanted something that I could use to cut aluminum with. I didn't want just a wood or plastic router. I looked at 3D printers and they just weren't for me. I'll probably still get one someday just because everybody's got one. But this is an actual 2 horsepower, I think it's a Ryobi. I'll have to look at it. I think it's a 2 horsepower Ryobi. And it does cut aluminum. The entire design was done by me. It's all 1/2-inch aluminum plate, so it's very, very rigid. And it has a pretty good sized bed. And mounting holes all through the bed on 1-inch centers, 1/4-20. And then I have a laptop running Mach 10. And then electronics that I designed and built. Should say mostly just kind of scrounged on eBay. It's got a pretty heavy-duty power supply in it, and then a breakout card from parallel to control signals, and a bunch of stepper motor drivers. It's got a current meter on the front. It's reading 4 amps right now. Some emergency stops. So there's a bazillion of these videos online, so I'm not going to spend a lot of time. I just kind of wanted to show the thing. I'm quite proud of my design. Here, let me flip this plastic out of the way so we don't get the glare off of it. And yeah, that's better. So it's got some NEMA motors. I think those are NEMA 23. No, I don't remember now. I don't know any of the specs anymore. It's been a long time since I designed this thing. It uses rails that are a round bar with a post in the middle. I took a look at using elevated bars, but they have too much flexure. And so these blocks here have a cutaway in them, so you always have something pushing up from the bottom, so they're very, very rigid. So the y-axis is very rigid, the x-axis is very rigid. The z-axis actually has floating bars in it because they're so short. I didn't have a lot of room in there, so they are floating, but it only goes up and down about 4 inches. What else can I say? It's got LED light in it, so I can see what the heck's going on. So let's see here. Let me do a 0 on it. Find home. So that's its home. It has a bunch of switches to do the homing. Now Mach 10 allows you to connect certain things. The first thing I had was this thing here. What do they call these things? Oh, there's a name for these things. Anyway, remote controls, but there's a particular name for them. You can move an X and Y, Z, emergency stop, things like that. I didn't find it very useful, so then I moved to this thing called a shuttle. This is made for video editing, and so it's a spin, variable velocity spin thing. And let me put it, if you push this button it moves in X, you push this button it moves in Y, you push this button it moves in Z. So you can see that if you move it just a little bit, I think you can hear that, it's moving very slowly. So different speeds, you can actually use this little wheel here to jog a step at a time. So you can use this to set the X position, the X position. So a lot of times the vise, I'll have the part registered in its upper left top corner. So you can see that the vise may be that. So if we want to move to that location, we'll go to Y, move in Y, we'll move in X, we'll move in Z, and just so I don't crash into anything, we'll say that that's now hovering above the solid jaw, the non-movable jaw, left top back. And we'll tell Mach 3 that that's 0. So I will say 0, 0, 0. And we have some G code. Let's see if we can make it run and do something. It's not doing anything. Let's see here. Stop. Load G code. Let's do this. And we will say cycle start. There we go. So you get the idea. It actually runs G code, and you can make all kinds of things. The very first thing I made was the tabletop. I drilled all of these 1-inch holes. I had the router actually drill its own holes, and then I went back and tapped them 1/4 by 20. Here's a little block that holds all my bits and collets, various size holes. And so I had it drill this out. I had it cut a speed handle for the milling machine, and it put in the hex holes. So it did that. That's pretty cool. Let me go grab a couple other things that I've designed with it. All right, this is the final speed handle. The other one was kind of a trial run, and I use this all the time. So that worked out. That worked out pretty good. This is a small little thing. Let's see if I can get it to focus on it. Of course, it's not going to focus. Hello, focus. Let me put it in the manual focus and see if I can't get it to come closer. There we go. So this is a cute little stop. This is a rip-off of a stop that's sold commercially. A lot of times you'll see them red anodized from the company who builds these things. But I actually designed this and had it cut out the little pieces. That came out pretty good. And then for something, let's see, for something a little bigger, this is, make sure I'm in focus here. There we go. So I cut out these S-shaped pieces. This is a stop for the mill. I only cut the side pieces on the CNC router. These pieces have some cutouts. I did those on the lathe and mill by hand. But I think you can see it does cut aluminum. It does do a pretty good job of that. I've cut other things. I've cut plexiglass, Delrin, obviously wood and aluminum. It does a pretty good job. It is a bit tricky to use, or first of all, it's tricky to find a laptop that has a parallel port. So this is one of the very last ones I think made. I got this out of the trash can at work, and it just needed a new hard drive, so I popped that in there. It's a compact EVO N410, so it's a really old machine. It's running Windows XP, I think, or Windows 7 or something. But it does have a parallel port, and the old CNC control boards were parallel port. I think everybody uses USB now. At the time I built this, that wasn't available yet. Yeah. Well, anyway, thought I'd show that to you. I'm gonna maybe start building some parts with it. So if I do build some parts, I'll make sure I create a video for that. I do have a Fusion 360 file for this router if somebody really wants it. It is a lot of kind of hit or miss. I didn't build it to the actual plan, but the plan is very, very close. I basically started building the thing by ordering parts, and then whenever I got a part, I would then rechange the CAD program to match the part that I got. And it was all designed off of this aluminum plate that I found in the trash can at work. So that sort of set the size of the machine. And then I kept buying parts and parts and parts. And every time I got a part, like a lead screw or something, I would update the CAD file to match what I purchased. And anyway, it ended up being what it is. I think, like I said, it's pretty sturdy. It's not the speediest thing in the world, but it is reliable. And if I had to do it over again, I bought a what do you call those things? These lead screws have a captured ball nut, and China makes a nice big one. This is metric, and if I had to do it over again, I'd use the same lead screw on both of them. This is a pretty coarse pitch. I have a very fine pitch up at the top, which was a Japanese lead screw that I found used. But it's a bit too fine for this application. I'd rather have the coarser one to speed it up a bit. So if I had to do it over again. But like I said, I tried to build the whole thing as cheap as I could. I believe that I built the machine for $500. That might not include the router. I think the router is another $100. It is a Bosch router. It's not a regular, it's a Bosch. I don't know the part number. Anyway, it's a Bosch router. It's 2 horsepower, and it's nice because it's round and it's easy to build clamps to install in the router. Yeah. Anyway, there you go.